Hi, my name is Amit. I'm on a mission of making AI so simple that anyone can understand it. In this episode, we will discuss what is the cost function of soft margin, what is hard margin and what is soft margin. Let's see that by an example. Till now we have seen there are two classes and these are our hyperplanes which are separating these two classes A and B. But in real life what happens? The points of each classes are not linearly separable. Some of them will be misclassified. Blue points are crossing this middle hyperplane which is our classifier. These red points are also crossing this hyperplane. These are getting misclassified. The cost function of SVM was find such W and B for which this is minimal. So this says that maximize this margin, but this does not tell you the control over misclassification of points. For that we introduce a new term zeta. For any point zeta is 0 if it is correctly classified, and zeta will be some positive value for incorrectly classified label. What will be this value? This is misclassified. This is coming after this line. It should come here. So what do? We take the distance of this point from here. This will be zeta. Okay, it will be some positive value, and then you take the distance of this point from this hyperplane, this one. And similarly for red points, you take distance from this hyperplane, these boundary hyperplanes, for this point from here. So these are all zeta, and then you take a summation of all the zeta for all the points. So this says we also have to minimize this classification error, and this is how we calculate zeta for each value. Maximum of 0, 1 minus yi, that is the actual label of the data, into the hyperplane equation. So this component here will make sure your margin is maximum, and this component will make sure your classification error is minimum. If you want to play around with this component, then you also introduce a variable c. If c is large, let's say 10, 100 or 1000, then you give more importance to classification error, and if c is lower, let's say 0.1 or 0.001, then you give more importance towards maximizing your margin. Sometimes we need this kind of setup as well. So what do we learn here? In this SVM classifier, where we only care about maximizing the margin, okay, of these two classes, this is called hard margin, because we are not allowing any of the misclassification here. And this is called soft margin, which is more practical. We introduce one more component, which is the summation of all the zeta i's. You place all these values, you regulate this term using a c variable, which you can give larger values to focus on this or minimum value to focus on this. So this is the equation of soft margin. If you have learned something today, then save this reel and follow for more such content.